Now we will begin with Kmeans clustering, and we will say its example, and then with the same example we will be seeing how to write the code. So now I won't discuss what is Kmeans clustering and all those ML stuff. I will directly jump to the example solving. So we'll be having this data set. So it's 2, 4, say minus 10, 12, 3, 20, 30 and 11. Then we will have this k. So k is the number of clusters and it will be 3. Then after this we have two ways. The first way is we can we have 3 clusters, so we can generate 3 clusters from these elements, or randomly we can choose any and we can make 3 clusters. Or the second thing which we can do is we can choose a centroid of our choice. So we will be using that way, the second way, for this example and for the program also. So we will be having this centroid. So let's take centroid 2, 4, 30. So to make this example quite simple, we will choose this centroid from these sets also. And it's far way better to choose the if we are using this way, then we should choose the centroid from the given elements also only. So centroid. Now we will calculate distance of this centroid. Like this is the centroid for cluster 1, for cluster 2, for cluster 3. So we'll calculate the distance of the centroid from the centroid of cluster 1 with 2, from 2 to 4, then 2 to minus 10, so on. Likewise the distance of 4 with 2, the distance of 4 with 4, distance of 4 with minus 10, and so on. And then again for 30, distance of 30 with 2, distance of 30 with 4, distance of 30 with minus 10, and so on. So let's write this distance. So I'm writing here cluster 0 because we are calculating the distance from the centroid of cluster 0. So now this is 0 to 12. Yeah, so from 2 to 2 the distance is 0, from 2 to 4 the distance is 2, from 2 to minus 10 the distance is 12, from 2 to 12 distance is 10, from 2 to 3 distance is 1, and so on. It will be 18, 28 and 9. Let me just check. Yeah, it's the, so I have already solved this example, so I will be quickly writing these distances. It's 2, 0, 14, 8, 1, 16, 26 and 7. Fine. Then again with cluster, with the centroid of cluster 2, which is 30, so it will be 26, no, sorry, 28, then 26, then 40, then 18, then 27, 10, 0 and 19. Fine. So now we got the distance of this data set from the centroid of cluster 0, 1 and 2. Now we will make a column like fashion of this matrix kind of stuff. It's not exactly a matrix, but we can say it's a distance matrix. So the reason why I have made this in column fashion is because we have to decide which is smallest among the columns. So we will see a column, so this is a column 0 to 28, this is a column, then 2, 0, 26, this is a column, and among this column we have to see which is the smallest element. So here 2 is the smallest value, and the smallest value corresponds to cluster 0, so that is 0 here. Here the smallest value is again 0 and it corresponds to cluster 1. So like 1 here. Here the smallest value is 12 and this 12 belongs to cluster 0. So like 0 here, and here the 8 is the smallest and it belongs to cluster 1. Here 1 is the smallest and it belongs to cluster 0. Here 10 is the smallest and it belongs to cluster 2. Here 0 is the smallest and it belongs to cluster again 2. And here it's cluster 1 because 7 is the smallest and it belongs to cluster 1. Fine. Now the reason we have calculated this is this we can say this represents the two, like which element will be going to which cluster. So if we map this with our data set which is given to us, then we can say that the first element will be going in the cluster 0, the second element will be going to cluster 1, the third element will be going to cluster 0, the fourth element in cluster 1, fifth in cluster 0, sixth in cluster 2, seventh in cluster 2, and the eighth element will be going in cluster 1. So now let's write this. So cluster 0. So this is the actual formation of the cluster. So to cluster 0, the elements which are coming in cluster 0 are the first, the third and the fifth element. So these first, third and fifth elements are 2, so minus 10 and 3. Cluster 1, it will be the second element and the fourth element. Fourth element is 12 and the last element which is 11. So these are coming to cluster 1, and now cluster 2, these two elements, that means the sixth and seventh element, 20 and 30. So now we got this cluster 0, 1 and 2. So these are the actual clusters. These are not clusters, these are the distance of centroid, like this is the distance of cluster of, like a centroid of cluster 0 to the data set, and these are the actual centroids. Fine, then we will take the mean here. So like we take mean here, that's why this algorithm is Kmeans. K is for number of clusters and mean because we take mean here. So mean of these will be 2 minus 10 plus 3 divided by 3. So this is, I think, minus 1. So it's actually 5 minus 5 divided by 3, and we will write minus 1 because we will take integer of it. That means like minus 5 divided by 3 is like 1.666. So we'll be ignoring the values after point and we'll be only keeping this single digit. So throughout the example we will not be considering this point, we will be just considering this int value. Fine. So here this is 12 and it will be 14 plus 25, 26, 27. So it will be, no, I don't think we have done. So is the first, second element and the fourth element. So here was a mistake. It was not 2, it was 4 because second element is 4. Yeah, 4, 12 and 11. 4, 12 and 11. Yeah, now it's right. Sorry, my bad. Just check, it was 4 here, not 2. So 4 plus 12 plus 26, 11, it will be 27, and divided by 3 gives us 9. Fine. and here it's simple, 50 divided by 2 is 25. So now these are the centroid value for these clusters. So we will now the new centroid. So this is our new centroid, and now we'll be using this centroid for further solving. So when we get this centroid, we start this whole process again. So like we can say, if I copy paste, yeah, we can say like at the starting we were having these three values, and from this we deduced all this. So again we are having these three values, and this time the centroid is new, and we will again find this distance, make these clusters, and find the centroid. Like these are the centroids. So distance cluster 0. So I have already solved this example, so I will quickly write these values here. You can just pause the video, or you can have the notebook and write these. So this will be 3, 5, 9, 13, 4, 21, 31 and 12 for cluster 0. For cluster 1 it will be 7, 7 is right, 7, 5, 19, 3, 6, 11, 21, 2, 21 and 2. And here it will be 23, 21, 35, 13, 22. If anyone is having problem like while writing these, you can just rewind the video to the point when I was writing this and explaining how to write this distance. So again, I'm making this in column wise fashion, so it will be more readable. Yeah. So here we get 3 is the smallest and it belongs to cluster 0, 5 is smallest belongs to cluster 0, 9 is smallest belongs to cluster 0, 3 is the smallest belonging to cluster 1, 4 is smallest belonging to cluster 0, cluster 2 and cluster 1. So now this is the values which we have got, and on the basis of this we will make the clusters. At any point, if you find any difficulty, just rewind to the part when I was showing how to write this, because every time we have to just repeat the steps that we have done here. Cluster 0 is cluster 0 will be the first 3 elements and then 5th element, so it will be 2, 4, minus 10 and 3. Then cluster 1 is the 5th element, no, sorry, the 4th element, which is 12, and the last element, which is 11. Cluster 2 is 20 and 30. Fine. So now here we have got the clusters. Fine. So now again we will, seems good to me, yeah, these are all correct. So now again we will find the mean here. So mean here will be, it's 3, 4 plus 6, 6 plus 3, 9, 9 minus like it will be -1 divided by 4, it will be 0 point something in minus, and as we are not considering the negative this 0, like we will not use the, it will be like we are not considering the values after point, so it will be -0 and there is nothing called -0, so we'll be having 0 only. Okay, I will, it's 9 minus 10 which divided by 4, which is -1 divided by 4, which is equal to 0 point like something, it will be 10.2 something, it will be in the minus. So as we are not considering anything like after my point, so we'll remove this, and there is nothing like -0, so we will remove this minus, and the centroid here will be 0. So for cluster 1 will be 23 divided by 2, which is I think 11 point, it's 10.5 I think, correct me if I'm wrong. So like we don't even need this point, so I'm not worried about that. So what we need is 11. So like we are not repeating again for the time being. We are, or even in the program, if we don't consider this, then also we will be getting the clusters. And if you want, you can there's no compulsion that we don't have to use this point, like values after this point. We can and we can't, so that doesn't make any difference. Only the values of cluster will change, so anyhow we have to make the cluster. So this makes our calculation simple in like when we are solving this example. So we will not be using this after point value. So here it's again 50 by 2, 55. So now we have got our new centroid, which is 0, 11 and 25. Fine. So this is the new centroid which we have got, and again we can begin some backward. Sorry for this. Yeah. So we can, like, we have to again like every time we have to just repeat these steps. So we can think of like starting from here and using this centroid this time. So again calculating the distance, cluster 0. I'm quickly writing the distances, you can follow up. (13, 22, 55 and 14). Let me check. Yeah, all these values look correct to me. So again arranging them to column fashion. Fine. So we will again decide which is the smallest and to which cluster it belongs. So it belongs to cluster 0, cluster 0, cluster 0, cluster 1, cluster 0, cluster 2, cluster 2 and cluster 1. Fine. So we will again map this with this and we will find the clusters. Will be 2, 4, minus 10 and 3. Step 2 will be 12 and 11. I'm absolutely sorry, this is not cluster 1, this is cluster 0, this is cluster 1, and this is cluster 2. It's 20 and 30 here. Fine. So again calculate the centroid. It's do look like the previous cluster that we have got. So yeah, this and this what we have got is same. So I will only write these centroid values, which is 0, 11 and 25. Fine. So the new centroid here is 0, 11 and 25. Now just a minute, let's say this was the relation one thing, small equation like this or like this. Equation 1, equation 2, equation 3. Yeah, so equation 1, equation now, yeah, this section is for equation 1, this is equation 2, and this is equation 3. Now do have a look at the centroid of equation 3 and centroid of equation 2 are similar. That means if you are on ith iteration and centroid of ith iteration and I minus 1 iteration are same, then it's the time to stop. Yeah, so like if we were on equation 3rd and the centroid of equation 3rd and centroid of equation 2nd, that is 3 minus 1, like minus 1th equation, if they are same, then this is the point where we stop. That means the final clusters which we got are these one. Copy this whole thing. So these are the final cluster that we got, and these are the centroids. So I don't think we need centroid here, we only need the cluster. So this is the cluster that we have got. So I will quickly describe how to do this step, because every time we have to just perform the same step till the point we don't get such scenario that where the cluster centroid of ith equation is equal to the I minus 1th equation. So we take we have centroid, we have data set, and we find the distance. To find distance, we just you can even do the arithmetic subtraction here to get this distance. It's like distance of 0 to 0, 0 to 4, 0 to 10, 0 to 12 for this cluster 0, so on. For cluster the distance of cluster 1, we'll use the centroid of cluster 1. For distance of 4 to 2, distance of 4 to 4, distance of 4 to minus 10, and we'll write here. And same for the centroid of cluster 3 and cluster 2, and we'll write here. After this, we see which is the smallest in this row, in this column, and this is 0. So smallest value is 0, and 0 belongs to cluster 0. Therefore, we will write 0 here. Here 0 is the smallest and it belongs to cluster 1, so we'll write 1 here. and the same way we will write this. So on the basis of this we decide these clusters. So like we can say the first element of the dataset will go in cluster 0, the second element will go in cluster 1, the third element will go in cluster 0, fourth in cluster 1, and so on, and that's how we make this centroid. This cluster. And on this cluster we can perform the mean of these clusters. So the mean will be the sum of all these divided by the number of elements, and that gives us the centroid for that cluster. And again we perform the same steps till the point we get this. Fine. So now let's begin with its program. So this is the code that we are having, and I presume all of you are having, and its link is also in the description box. So let's start. So this is the data which we were having. It's the same array, the same values, and number of clusters is same, the k value is 3, and this is the centroid that we will be using. So we have made like 2D array here, because, and we have kept this is 0 and this is the centroid which we will be using. The reason to make a 2D array here is because every time like when we will find, so like what we were doing here, we were just using that centroid, but in the program after getting a centroid at any step we will just swap it with the we have to check whether it's this is equal to the previous centroid. So that's why we need the to keep the centroid of previous iteration. So that's why we'll be using 2D array, so to keep the centroid of the previous iteration. Fine. So we have made a function to get centroid, and we'll be passing the data, the number of clusters, and the centroid. Like this is centroid of the previous centroid. So this program will exactly same as the we have discussed the numerical. So we'll be having this distance matrix. So distance matrix will be initialized with the number of clusters and the length of the data. Then we'll be having the cluster. It will be initialized with the length of data and the cluster node count. So cluster node count, that means if this is cluster and it is having 4 nodes, so then the cluster node count variable will store 4. So this is to keep the total number of elements in that cluster. Fine. So now centroid 0 equals to centroid 1 and centroid 1 equals to 0 0. That means this means a blank, like we have initialized it. It is similar to that we have initialized to the null. So this is the step where we will be storing the previous we will storing the centroid of the previous iteration. So what we like in the previous we have stored the, like in the 0th we will have stored the current, and the current we initialize to 0, and okay, I will just remember the centroid 0 and centroid 1. So what we do here is, this is the centroid 0 and this is the centroid 1. So every time what we do is, when at the end of this we make this, we save this in the centroid 0, and the centroid 1 is set to 0 0, and at next step we calculate the centroid 1 and we check whether centroid 1 and centroid 0 are similar. So these are centroid 0 and centroid 1. Fine. So now we will calculate the distance here. So we will be using 2 for loops. The first for loop will be for till the number of clusters, and second one will be till the length of the data. So length of data is the till the number length of data will give the total number of elements in this set. Fine. So to calculate the distance we will use this abstract method, and we will just divide with the element in the data to the centroid. That means we will be actually dividing 2 minus 2, 4 minus 2, minus 10 minus 2, and we will be using the abstract of this because it's a distance, so we don't have to use those signs. Fine. And we are just printing the distance. So till here what we have achieved is this. So like when the program will execute till here, like till the end of this for loop, this thing will be generated. Fine. Now the second thing is, now we have to generate this. So to generate this, we will be using till the length of data, because its length is also the same as the length of this data. When the number of elements here and the number of this is same, so we will run this for loop till the length of data, and we will set the smaller distance to 0. And if this distance of 0 and j means this, like you can say, if the distance of, like if the value of this is greater than if the value of this is smaller than this, and if the value of this is smaller than this, then we will set this as 0. So if the value of 0 comma j is like the data, so 0 comma j is like j will be the counter for from 0 to length of data. So from 0 to j, if it's less than 1, and if again 0 is less than 2, so we can say like 0, just remember this 0, 1 and 2. So we can say if 0 is smaller than 1 and 0 is smaller than 2, then we will write 0. And here if 1 is smaller than 0 and 1 is smaller than 2, that means if 1 is smaller than 0 and if 1 is smaller than 2, then we will write 1. Fine. And the same way, if the 2 is smaller than 0 and 2 is smaller than 1, it's here. So like say if 2 is smaller than 1 and if 2 is smaller than 2, like 10 is smaller than 16, then we will write 2. So this smaller distance, this contains all these values, like what we were generating here, or we were calculating here. Fine. So this way we have so now after this we just so now we have these values. Now it's time to, so after this, like when this will end here this part, we'll be having this, like we got till this. Now it's time to calculate the clusters and do the summations. Fine. So this line, this actually adds all the elements within that cluster. Then this cluster node count increases itself one by one as the number of data goes, like the length of data goes on in a particular cluster, and the cluster j equals to smaller distance. So this is this cluster j contains this thing, so that like it's an array, like in the program it will be an array. So this cluster j will be having the value of this 0 and this value. Fine. Now till this point we got the values till here, and we have got the total number of elements in this and the sum of this. So the next thing we have to do is we have to generate these clusters. Fine. So this is the logic for generating the cluster. So what we are using is two for loops here. The one is from the number of clusters, and second is for the length of data. So for cluster C I plus 1, for the for zeroth cluster, we will be having like if just now this is the tricky part, so just listen carefully. If L is 0, like L will begin from 0. If cluster of L equals to 1 equals to I, so for the first time it will be I will be 0, and the value at cluster 0. So what is the value of cluster 0? So just copy this. Yeah, so just imagine this is the cluster array right here. So this is our this is a cluster array, and this is index 0, 1, 2, 3, 4, and so on. So at when I is 0, when L is 0, so at the 0th position of cluster 0 is 0, and which is equal to 1. So we'll write the data of L, that means the data of data at point of L. So L will be the 0. So data, what is our data matrix? So this is our data values. So we will write, so the data of L was 0, so we'll write 2. Then so now this inner for loop will iterate, so this will become 1 if 1 equals to 0. So the data, like the value at cluster 1, the value at cluster 1 is 1 and it's not equal to 0, so this won't come under this cluster 1. So like this outer for loop will be for the clusters, so like it's till the number of cluster, that means it will run only for cluster 0, 1 and 2. So whatever we will be seeing in this inner cluster will be for in this inner for loop will be for the particular cluster. So the second element won't enter in the cluster 1, like cluster 0 we can say, as our I is still 0. Then it was 0, then it was 1, now it will be 2. So the value at cluster 2 is 0, and yes, it is equals to I because I is still 0. So the data corresponding to that L, that means the third position, that is 10, will come in this cluster 0. So let's see, this is what was happening here. At the first time when the so now our outer for loop is like outer for loop, that means I is 0. So in the inner for loop where L is there, so L is equal to 0, the value of, that means this is the cluster, so value of cluster at Lth position and L is 0 is 0. So this 0 and this 0 is equals to I means 0, like there. So the data element at position L means 0 will come in the cluster 0. Fine. So it was too many 0 0. I will discuss this once again. So now this L has incremented to, it was 0, 1, 2, now it will be 3. So cluster, the value of cluster at point 3 is 1, which is not equal to I is still 0 because we are still talking about the cluster 0, so it won't come in the cluster 1. Now the L will again increment and it will become 4. So the value of the value at cluster 4 is 1, 2, 3, 4, no, like 4. So value 4 is, sorry, 4 is this, sorry, 0, 1, 2, 3 and 4. Yeah, so for the value is 0 and this value, so like this value is equal to I because I is still 0, we are still talking about the first cluster. So the data corresponding to L at L means 4, so at the fourth position of data, 1, 2, 3, 4, here is the 3, so that's why 3 came here. So on the same way these clusters will be generated. So after this cluster, so like I have discussed till cluster 0, and the same way it will be for cluster 1 and 2. Now after we have generated this these clusters, the next step we do is to get the centroid. So getting centroid is quite simple, as we have already taken the sum of this centroid and the total number of elements in that centroid, so we will just divide them here is the division, and you will just calculate the centroid. So after this centroid, what was our next step is just to check whether this centroid that we have got here is equal to the previous centroid or not. So we will check here, like is achieved means that is the clustering has achieved or not. So we will check for the number till the number of clusters. We will check if the centroid at 0 is equal to, I just don't look at this j, just simply think that if we are at this ith position, so the centroid at I minus 1th position are same or not. If they are same, then yes, we have achieved, it's will be true and we will continue. Otherwise, if we have not achieved, then we will calling the same function. That means we are doing the recursion and we will follow these steps again. So the same way we were doing here, if like when these two are not equal, that means, so that's why we did this whole thing again. So again these were not equal, so we did this whole thing again, and when we got these things equal, so we reached to the final cluster. So when in case if becomes true, like when we reach to our clusters, like when the centroids become equal, at that time if it's true, then we just write the final cluster, and final cluster is same as the cluster which we have got at the ith iteration, and that ends the program. So for now this program is running for only for the number of cluster 3. I will try to make it generic, like we can choose any number of cluster here and any number data set, and we can, and the code will work. So I will see to it whether I can do it or not. So if in case I will do it, I will post the link for that program, and if not, like even you can also try. The only thing which we have to change to make it generic is this: we have to change this, like we have to create an array of this smaller distance, and then I think it might work, because like the only problem here is this, like we have hard coded it for cluster 0, cluster 1 and cluster 2, so just we have to make this dynamic, and I think then it will work for any number of clusters. So this is what I could have explained, and that's the max I can do. Like I just now, the Kmeans was a bit tough. Fine then, this is all about Kmeans.